Bismillahirrahmanirrahim. I am Dr. Muhammad Hanif, and today we are going to discuss a topic named as dot product. It is also called a scalar product. So how to define a scalar product, a dot product? If two vectors multiplied and result into a scalar quantity, then this product is called dot product. If we have two vectors and we take the dot product, we will get scalar. In earlier classes, we have already learned about dot product. So we know that A vector dot B vector, if you are taking the dot product of A and B, you will get AB cos theta, where A and B are the magnitudes of vector A and vector B. What is magnitude? Magnitude is a size. Magnitude is a numerical value, or magnitude is a number. So these are just numbers. It is a magnitude. It is a scalar quantity. After multiplying vector A and vector B, we will get scalar. And theta is angle between vector A and vector B. And you already know the values of cos 0, cos 90 and many more. So dot product in terms of rectangular components. So how to multiply two vectors in terms of their rectangular components? In 3 space, we know that a vector have 3 coordinates, x, y and z coordinate. And you already know that along x-axis I unit vector exists. And how about I unit vector, j unit vector and k unit vector? Actually, they are the unit vectors whose magnitude is 1. So if you want to define a unit vector, what is unit vector? Unit vector is a vector whose magnitude is 1, means whose value is 1. So what is the purpose of unit vector? Unit vector shows the direction of a given vector. Let's suppose we have a vector A, 2i unit vector plus 3j unit vector plus 5k unit vector. Then how you know the position? How you know the direction of this? Because this is an I unit vector, so we know that it is along x-axis, and it is j unit vector, it is along y-axis, and it is k unit vector, so it is along z-axis. So how to multiply a vector in terms of their rectangular components? So let's suppose in general I am taking a vector in 3 dimension. In 3D, A vector is equal to AXI, AYJ and AZK unit vector. Another vector B, BXI unit vector plus BYJ plus BZK unit vector. So, if you take the dot product in terms of the rectangular component, you just need to multiply the coefficients of I unit vector of A and coefficient of the I unit vector of vector B. Just you need to multiply these coefficients with each other. X component with X component, Y component with Y component and Z component of A vector with the Z component of B vector. So it is very easy. When you will see the example, you easily remember that. So So final result is this: A dot B is equal to A vector dot B vector is equal to AX BX plus AY BY plus AZ BZ. Why? Because I unit vector dot I unit vector, after applying this formula, we will get I unit vector magnitude cos theta. And you know that if we are taking a dot product of a vector with itself, we will get I dot I cos theta. And by taking, if I am taking the dot product of I unit vector with I unit vector, so they are parallel to each other and they create angle 0 degree. So cos 0 is 1. Here this is magnitude. We know that in unit vector, so its magnitude is 1. Its magnitude is 1 and cos 0 is 1. So I dot I is equal to 1. But I dot j, j dot k and k dot I is equal to 0. Why? Reason is that because they are perpendicular to each other. When we draw, this is I, this is j and this is k unit vector. So it is a rectangular coordinate system because they are orthogonal to each other. They are perpendicular to each other. Why? We already know these things very well. These are, let's suppose this is I unit vector, j unit vector and this is k unit vector. They are perpendicular to each other. Perpendicular means I and j, they have angle 90 degree. So that's why cos 90 is 0. So that's why I dot j must be equal to 0. Similarly, j dot k is 0, k dot I is 0. So we got two results. I unit vector dot I unit vector, j dot j and k dot k must be equal to 1. But different unit vectors have dot product must be 0. Example, this is a vector 2i 3j plus 5k and b vector 3i plus 2j minus 2k unit vector. So I want to take a dot product of vector a and b. So it is very simple and easy. You just need to multiply the coefficient of I of vector a and the coefficient of I of vector b. So just 2 3s are 6, 3 2s are 6 plus 5 into minus 2. Minus 10. So 2 3s are 6, 3 2s are plus 6, 5 minus 2, 10. So 6 plus 6, 12, 12 minus 10, you will get 2. So the multiplication of two vector is very easy in terms of their rectangular components. Just you need to multiply the x coefficient with the x coefficient, y coefficient with the y coefficient, and z coefficient with z coefficient, and just add them. You will get the dot product of two vectors. Next, so there are some characteristics, properties of a dot product. So dot product have commutative property. In dot product, commutative property exists. What is commutative property? Commutative property is a vector dot b vector must be equal to b vector dot a vector. If you are taking the dot product, you can replace a with b and b with a. So there is no difference. Why? Because they are different vectors. So ab cos theta, this will become ba cos theta. I know that this, if you take the dot product a dot b, you will get ab cos theta. If you replace b with a and a with b, so you will get ba cos theta. And these a and b are magnitudes. So if they are magnitude, so you can multiply 4, 5 and you will get 4.4. They must have same values, 20. This is also 20. A and B are the magnitudes. So I am taking A 4 and B equal to 5. Then I replace first value is 5 and the second value is 4. You will get the same values. So A vector dot B vector must be equal to B vector dot A vector. So in dot product, commutative property exists. Also distributive property, you can prove that easily. Just take three vectors, A vector dot B vector plus C vector. You will get A vector dot B vector plus A vector dot C vector. So it is very easy to prove. You can prove by yourself. Constant multiplication. You can multiply a 2 vector by a constant. So you can take the constant with a vector. You will take a vector and b vector together and see outside a vector dot c into b vector. So there is no problem if you are taking a vector with a constant, 2 vector with a constant, constant with a, constant with b. So no problem with constants. Just you need to multiply a constant by a vector. So it is very easy. If you multiply a 0 vector, a null vector with a vector a, you will get 0 vector. Not 0 vector, sorry, you will get 0. 0 because we know that if 2 vectors multiplied, the answer is scalar. So 0 is a scalar because it has no direction. So you no need to write 0 vector. Here I must need to write 0 vector because 0 vectors, I can take the 3 component of 0 vector. 0 I unit vector plus 0 j unit vector plus 0 k unit vector, and then I will multiply with a vector. And a vector let have 3 coordinates a1, a2 and a3. After multiplying 0 with individual x, y and z, we will get 0 vector. Fifth characteristic of this dot product is this: a vector, a magnitude of a must be equal to a vector dot a vector square root. Square root of a vector dot a vector. So I am going to solve this property. It is very easy, not a difficult task for us. You can see here a vector dot a vector. So I am taking the components of a vector a1, a2, a3. So these are the component of vector a1, a2 and a3. I am taking the dot product by itself. So a vector a1, a2 and a3. They are the similar vectors. So you can see here. So when we take the dot product, you know how to take a dot product in terms of rectangular components. So it is x component, just need to multiply these 2 components. This is a y component, multiply by y. This is a z component, you need to multiply with a z component. So you will get a1 square plus a2 square plus a3 square. So a vector dot b vector becomes equal to a1 square plus a2 square plus a3 square. I think you don't have any issue if I take the square root and then square, because square and square root finish. So you know that this is a definition of magnitude. If you want to take the magnitude of any vector, you just need to take x component square plus y component square plus z component square and square root. This is the definition of magnitude. So inside the bracket, this is a magnitude and square. So a vector dot a vector becomes a magnitude square. So if you take square root on both sides, you will get the required result. Means a magnitude equal to square root a vector dot a vector. Example 1, we have a vector v, their coordinates are 1, minus 3 and 2. W vector minus 2, 4, 1. And u vector 2i minus 4j plus k unit vector. You no need to worry about that. This is vector, this is also a vector. Just it is written in terms of position vector. So if you want to write down the position vector of u, you can write 2, minus 4, 1. So I need to solve this equation, v vector dot into w vector plus v vector. So v vector dot w plus v vector is equal to, we know that v vector's value is 1 minus 3 2, 1 minus 3 2. Position vector w plus v vector, just need to add w and u. So minus 2 plus 2 0, 4 minus 4 0, 1 plus 1 2. Just we need to add the x components, y components and z components of vectors u and v. W and v. So I got two vectors, position vectors of two vectors. So when we take the dot product, I need to just multiply 1 with 0 plus minus 3 with 0 plus 2 with 2 and you will get the answer 4. Example 2, v dot w into u vector. So what is v dot w? V dot w, I need to take the dot product of v and w, and you know the dot product of two vectors. How to take the dot product of two vectors? Just you need to multiply 1 with minus 2, so you will get minus 2, minus 3 with 4, minus 12, 2 with 1, you will get 2. So when we add these things, so minus 2 is deleted by plus 2. So here outside we will get minus 12. And this is you can write just same as it is. 2i unit vector minus 4j unit vector plus k unit vector.